300 miles off the Oregon coast, the most active volcano in the United States is fully loaded. Its magma reservoir has refilled past the level that set off its last eruption, and the scientists watching it say the next one is due before this year ends. More than 140 instruments are pressed against it. A sealed prediction of the eruption date already exists. And yet, the volcano is getting quieter by the month, and nobody can explain why. By the end, you'll know the single number that reveals how close it really is. There is exactly one volcano on this planet with a public, dated eruption forecast attached to it, and that forecast expires on December 31st of this year. The volcano is called Axial Seamount, and the scientists who study it have gone on record, at conferences and published updates in front of their own colleagues, saying it will erupt before the end of 2026. That is a little over 4 months from now, and here is the part that should get your attention. The volcano is ready. Its magma reservoir has refilled past the level that set off its last eruption. Every physical precondition the forecast is built on has been met, the tank is full, the trigger line has been crossed, and yet month after month, the volcano is doing something nobody predicted. It is going quiet. This is not a small scientific footnote. This is the most closely watched volcano on Earth, wired with more than 140 instruments, monitored in real time through hundreds of miles of fiber optic cable on the seafloor, with 2 separate forecasting efforts, one public, one sealed, betting on when it breaks. If the forecast holds, it will be the first time in history that scientists called a volcanic eruption more than a year in advance, twice. If it fails in front of everyone. Either way, the clock is running and the volcano knows something we don't. Axial Seamount sits roughly 300 miles west of the Oregon coast, about 480 kilometers out, with its summit around 4,600 feet below the surface of the Pacific. It is a submarine volcano. You cannot see it, you cannot visit it without a submersible, and if it erupted tomorrow, nobody on shore would feel a thing. But by eruption frequency in the modern instrumental era, it is the most active volcano in the United States. Not Kilauea, not Mount St. Helens. Axial. The volcano exists because of a rare geological coincidence. A hotspot, a plume of rising magma from the mantle, sits directly on top of the Juan de Fuca Ridge, a mid-ocean spreading center where 2 tectonic plates pull apart. That combination gives Axial an unusually generous fuel supply. Its summit holds a caldera roughly 100 meters from rim to floor, with rift zones running about 50 kilometers to the north and south. In the modern instrumental record, it has erupted 3 times: January 1998, April 2011, and April 24, 2015. 3 eruptions in under 20 years, each one recorded by instruments sitting on the volcano itself. The intervals between those eruptions tell you something important about how irregular the system really is. 13 years passed between 1998 and 2011, then only 4 years to 2015. And now the volcano has gone 11 years and 4 months without erupting, nearly the longest quiet stretch in its instrumental record, and counting. A volcano that erupts every 4 years and a volcano that erupts every 13 are 2 very different animals, and Axial has been both inside a single generation. That record, frequent, recent, and measured rather than reconstructed, is exactly why scientists believe this volcano, alone among all volcanoes on Earth, might be predictable. And that belief is now being tested in real time, in public, with a deadline attached. The forecast rests on a mechanism so simple it almost sounds too good to be true. Axial behaves like a slow balloon. Between eruptions, magma refills the shallow reservoir beneath the caldera, and the caldera floor physically rises. Inflation, measured to the centimeter by bottom pressure recorders sitting on the seafloor. When the volcano erupts, magma drains out and the floor drops abruptly. Then the cycle starts again. The key discovery came from comparing the cycles. Each eruption appears to trigger at or near the inflation level the volcano reached before its previous eruption. The 2015 eruption triggered at a threshold about 30 centimeters higher than the 2011 threshold. So the working assumption became the next eruption should trigger somewhere between the 2015 level and roughly 30 centimeters above it. It is a pressure gauge with a red line drawn on it. Here's where the story stops being comfortable. As of late October of last year, the caldera floor stood about 10 centimeters above the 2015 trigger threshold, with perhaps 20 centimeters of headroom left before the top of the danger band. Read that again. The volcano is not approaching the red line. It is past it. It has been past it for months. By the logic that successfully called the last eruption, Axial is inside the window where failure can happen at any time. Bill Chadwick of Oregon State University and Scott Nooner of the University of North Carolina at Wilmington, the 2 researchers behind the forecast, first predicted an eruption by the end of 2025. The volcano ignored them. On December 31st of last year, they formally revised the deadline before the end of 2026. The second deadline is now burning down, and the reason they believe they can still call it comes from the one time they already did. In 2014, Chadwick and Nooner did something almost no volcanologist is willing to do. They published a forecast in public that Axial would erupt in 2015. 7 months later, it did. The forecast was met with the polite skepticism you would expect. Volcanologists have been burned by predictions for a century, and the field's standing rule is that you talk about probabilities, never dates. Chadwick and Nooner named a year anyway, because the data gave them the confidence to do it. On April 23rd and 24th, 2015, the seafloor instruments lit up. In roughly 24 hours, the network recorded approximately 8,000 earthquakes. The caldera floor dropped 2.4 meters, nearly 8 feet. As magma drained out of the reservoir and poured into the North Rift Zone, lava erupted along about 7 kilometers of the rift. One flow lobe was so thick that a remotely operated vehicle later drove up its face for 90 meters, 295 feet of brand new rock, stacked in a single event. It was the first submarine eruption ever recorded live by an in-place cabled observatory. And in the weeks that followed, dive teams found something remarkable. Fissures nicknamed snowblower vents, blasting out white flurries of microbial material. Life, blooming explosively on the chemical energy of fresh lava within weeks of the eruption. That 2015 success is the entire reason the current deadline exists. The forecast worked because the volcano was refilling fast and steadily, about 70 centimeters of uplift per year, which made the arrival time at the trigger threshold a matter of simple extrapolation. Draw the line, mark the date. The volcano cooperated. And that is precisely what makes the current situation so strange, because this time, the volcano has stopped cooperating in a way nobody has an explanation for. Everything volcanology teaches you to expect from a volcano approaching failure runs in one direction. Things speed up. Earthquakes multiply. Inflation accelerates. The system gets noisier as the rock gets closer to breaking. Axial is doing the opposite, and the numbers are hard to look away from. Before the 2015 eruption, the volcano was producing around 2,200 earthquakes per day, sustained, climbing to roughly 8,000 in the final 24 hours. As of December of last year, it was producing about 300 a day. Through the spring and summer of this year, fewer than 100 a day on most days, with occasional bursts of a few hundred. There have been isolated spikes. One day in late July of last year topped 2,000 quakes, and a few days in October went over 1,000, but nothing sustained. The signal flares up and dies back over and over. Each spike looks for a day or two like the beginning of the run-up everyone is waiting for. Then it collapses back to background and the countdown resets. Those bursts matter more than they might sound, because they show the machinery still works. The magma pathway is open, the reservoir can still surge, and the rock above it still cracks when pressure rises. Whatever is happening at Axial is not a shutdown. It is a throttling, an engine idling when every gauge says it should be redlining. The inflation record tells the same story. Before 2015, about 70 centimeters of uplift per year. In July of 2024, when the first forecast was issued, about 25. By late last year, about 16. And through this year, in the differential pressure record measured against the caldera's eastern rim, the 6-month average fell from 10.6 centimeters per year to 6.5, while the 3-month average sank to just 4.5 by late July. The rate of refill has roughly halved, twice inside a single year. In their March update, the researchers wrote it plainly. We were anticipating an increase in seismicity before the next eruption. Instead, the opposite is happening. And when Chadwick addressed the cause on March 17th, his answer was 5 words long. We don't know what it is. Something about the supply of magma to this volcano is changing, and the people who know it best cannot say why. Stop and hold both of those facts side by side, because the entire mystery lives in the gap between them. The reservoir is fuller than it was at the moment of the last eruption, and the system is quieter than it has been at almost any point in the last decade. A fully loaded volcano should not be this calm. There are 2 broad ways to read it, and they point in opposite directions. The first reading says the slowdown is a reprieve. If the magma supply from the hotspot below has genuinely throttled back, then pressurization is slowed, the failure point drifts further into the future, and the end-of-year deadline quietly dies the way the last one did. The second reading is less comfortable. The threshold mechanism has never actually failed. Every instrumentally recorded eruption honored it. If the trigger band is real, Then Axial is sitting inside it right now, and the slowdown only means the final push is arriving slowly. Under that reading, any renewed pulse of magma, the kind of surge this volcano has produced repeatedly since 2015 in fits and starts, could carry it to failure fast. The slowdown stretches the timeline. It does not diffuse the mechanism. The researchers themselves have been unusually blunt about what this has done to their method. In the December update that reset the deadline, they admitted that simple pattern recognition forecasting has proven to be unreliable, for the simplest possible reason. The pattern can change. The threshold has held, eruption after eruption. The refill rate, the part you need for timing, has broken every extrapolation since 2015. And to their credit, they have said it out loud. The failed 2025 deadline was not buried or reframed as a near miss. It was documented, dissected, and published in more detail than the successes. Chadwick's own updates have criticized waves of media coverage that recycled could erupt any day headlines, while, in his words, nothing had changed. The team openly worries about moving the goalposts. That candor is worth noting because it means the current deadline is not hype. It is a working hypothesis, published by people who have already paid the price of being wrong once. So they built a new metric, and it comes with a number you can watch yourself. The revised forecast abandons the question of how high the caldera floor is and asks a sharper one. How broken is the rock? The new metric divides earthquake count by uplift. The number of earthquakes the volcano produces for every centimeter the floor rises. In the 3 months before the 2015 eruption, that value climbed to roughly 10,000 earthquakes per centimeter of uplift and held there. The researchers suspect that number marks a physical transition. The moment the rock around the reservoir stops flexing elastically and starts genuinely failing, crack by crack, on its way to letting go. Since 2015, the normalized rate has climbed gradually with isolated days near the danger zone, but it has never sustained that level. At the current crawl of uplift, crossing the threshold would take seismicity in the neighborhood of 500 earthquakes per day. That is the countdown number, not 5,000, 500, sustained day after day. And because the University of Washington maintains the earthquake catalog in near real time on a public feed, anyone, including you, can watch that daily count and know roughly where the volcano stands. Based on the mathematical relationship between cumulative uplift and earthquake count, the team expects that threshold to be crossed before the end of this year. That is the standing forecast, on the record, with 4 months and change left on it. And there is a second forecast, one nobody is allowed to see. Beginning in the week of November 12th of last year, a fully independent experiment started running on the same live data stream. A physics-based mechanical failure model built by Tsinghua Lei of Uppsala University in Sweden and Didier Sornet of ETH Zurich in Switzerland. Their model has previously predicted failure times in retrospect for landslides, rock bursts, collapsing glaciers, and volcanoes, including Axial's own past eruptions. Now it is running forward on real data, generating a forecast eruption date at least once a month. Here's the twist. They are not publishing the dates, not until after the eruption happens. The reason is scientific honesty. If you announce a prediction and then quietly adjust it, you can always claim success after the fact. By sealing every forecast and committing to publish all of them, hit or miss, once the volcano erupts, the method gets an honest grade. But sit with what that means. Somewhere, right now, there is a dated prediction of this eruption, generated by a model, updated monthly, locked away, and nobody outside that experiment knows what date is written on it. The volcano's deadline exists in 2 versions, one public and expiring in December, one sealed and unknown. The choice of Axial for this experiment was not an accident. A model like this needs 3 things: a system that actually fails on human timescales, instrumentation good enough to feed it continuous data, and a setting where being wrong hurts no one. Axial is the only volcano on Earth that offers all 3 at once. If the sealed forecast turns out to have named the right month, it would be a landmark. Evidence that the failure of rock under pressure follows mathematics. You can compute in advance whether that rock is a hillside, a glacier, or the roof of a magma chamber. There is one more wrinkle in the timing, and it is either meaningless or very important. All 3 recorded eruptions, 1998, 2011, 2015, happened between January and April. Published work has shown Axial's earthquakes concentrate at low ocean tide when the weight of water pressing down on the caldera is at its minimum, so a seasonal window is not physically absurd. With a sample size of 3, nobody can say if it is real. But notice where the next January to April window falls. The first 4 months of 2027, starting the month after the public deadline expires. Now, for the part of this story that has nothing to do with magma, and it may be the most consequential part of all. Everything you have heard so far, every centimeter of uplift, every earthquake count, every forecast, exists because of one piece of infrastructure. The regional cabled array, part of the federally funded Ocean Observatories Initiative, operated by the University of Washington. It is a roughly $386 million facility, about 660 miles of fiber optic cable running across the seafloor, delivering power and bandwidth to more than 140 instruments, pressure recorders, tilt meters, seismometers, hydrophones, all streaming to shore in real time. That cable is the only way anyone can see this volcano. Axial's earthquakes are almost all magnitude 2, or smaller, far too small and far too distant to register on any land-based seismic network. No cable, no data, no forecast. If the array went dark, the most active volcano in the United States would simply vanish from view. The earthquake catalog itself is maintained and displayed in near real time by William Wilcock and Mao Chuan-Zhang at the University of Washington, the same public feed where the 500-a-day countdown number will show up, if it ever comes. And this year, it very nearly did. On May 21st, the National Science Foundation announced a major descoping of the Ocean Observatories Initiative. A plan, first reported nationally in early June, that would have dismantled the ocean monitoring system in the middle of the forecast window. The reaction was immediate. Bipartisan pushback in Congress, led by Oregon Senator Jeff Merkley, forced a reversal. And on June 18th, the administration backed down, partially. Under the current plan, every other OOI array is still being discontinued. The regional cabled array survived, but with funding confirmed only through September of 2028. And reporting in late June confirmed that core research programs, including the very program that funds the axial forecasting work, are still facing cuts. So this story is now a race between two countdowns. The first is the volcano against its threshold, fully loaded past the trigger line, deadline in December. The second is the observatory against its own funding horizon. September 2028, with no guarantee beyond it. If the volcano keeps stalling, if the magma supply stays throttled and the eruption slides past the deadline, past the calendar window into 2028 or beyond, the second clock starts to matter more than the first. Consider what that outcome would actually mean. 2 decades of monitoring, hundreds of millions of dollars of infrastructure, more than 140 instruments pressed against the volcano's surface, waiting for one specific moment. And the eruption arrives after the cameras are switched off. The best instrumented volcano on Earth would erupt unobserved, and the entire experiment would end one eruption short of its answer. That is not a hypothetical worst case invented for drama. It is the plain arithmetic of a stalling volcano and a dated funding line, and the researchers are aware of both numbers. There is also a quieter irony in how close the shutdown came. The dismantling plan was announced while the forecast window was open, while the volcano sat past its trigger threshold. Had the reversal not come 3 weeks later, the array would have been wound down during the very stretch of months the forecast points at. Science got lucky in June. Whether it stays lucky through 2028 is a question that will be answered in budget documents, not in seismic data. And for this volcano, the two have become inseparable. Let's clear one thing up first, because every time Axial makes headlines, the same claim starts circulating, that an eruption will set off the Cascadia megathrust or send a tsunami into the west coast. The data says no, flatly. Axial sits 300 miles offshore on a spreading ridge, a completely different tectonic system from the Cascadia subduction zone at the coast. Its eruptions are gentle, effusive lava flows a mile underwater. The 2015 event produced 8,000 earthquakes, and essentially all of them were magnitude 2 or smaller. No wave, no coastal shaking, no trigger. The United States Geological Survey and the research team say it plainly. This volcano poses no threat to people. If Axial erupts tonight, the only casualties will be microbes and forecasting models. That is exactly why this volcano matters so much. Axial is the one place on Earth where scientists can test eruption forecasting with real stakes for the science and zero stakes for human life. A natural laboratory where a blown forecast costs nothing but pride. The ambition behind both forecasting efforts is to move eruption prediction from pattern matching to physics, the same transition weather forecasting made in the last century. If the method can be proven here, the goal is to carry it to volcanoes that sit above cities, where 7 months of warning would be measured in lives instead of conference talks. So here is what to watch between now and December 31st. Watch the daily earthquake count on the Public University of Washington feed. The countdown number is 500 per day, sustained. Watch for any renewed surge in the inflation rate because the reservoir is already past the trigger line and a fresh pulse of magma could close the distance fast. And watch January through April of next year, the window every previous eruption has chosen, sitting just past the deadline. Either Axial erupts inside its window and proves that eruptions can be scheduled, or it stays quiet and proves that even with every instrument we own pressed against its skin, we still cannot read a volcano's mind. One of those answers arrives within months. We'll be tracking it either way.